Lisp has first-class functions, easy to define, can be passed as parameters, can be returned as values from other functions, anonymous functions too. Lisp uses pairs. Lists are chains of pairs. Can make other trees etc. as well. Lisp does lots more. File and file input output. Advanced object system using generic functions and message passing. Text formatting. Fancy iteration constructs, conditions and restarts. Libraries for other things. Some key facts about Lisp. The basic execution unit in Lisp is the form. Lisp runs in a read-eval print loop. When a Lisp form is typed, it is read, evaluated and its value is printed. Forms can be literals, bound variables, functional calls, etc. Sometimes forms are called S expressions. The basic component of Lisp programs is the function. Every function in Lisp returns some value. Some functions carry out an action. This action is called the side effect of the function. Programs are a collection of functions. Whereas Pascal has only 12 basic types of statement, Lisp has literally hundreds of functions. Lisp is a functional language, though not a pure one. The basic data units in Lisp are the atom and the list. Atoms. Atoms are indivisible units. To us they look like identifiers. Atoms can function as the names of variables. In example, they can be bound to values. Atoms can also function as the values of variables. Lists. Lists are ordered sequences of elements. The elements are either atoms or lists. Therefore, lists are recursive structures. Lists are written in the following manner. Notice there are no commas separating the list elements. A list has a head called the first or the CAR. A list has a tail called the rest or the CDR. Therefore, syntactically there is no differentiation between code and data. Semantically, one may treat a given list as data at one point and as code at another. Therefore, one can readily have a Lisp program generate executable code. Const is a predicate which is true if its argument is a list but is not nil. Null is a predicate which returns true if its argument is nil. Lisp is an extensible language. Since a large part of Lisp is the set of predefined functions, adding to that your own set of functions creates, in effect, a new expanded version of Lisp. That is how Lisp came to have so many functions. Thus, Lisp is to some extent a user-defined language. Lisp is a high-level language. Lisp can be either interpreted or compiled. The Lisp interpreter. Lisp basically runs in a read-eval-print loop. Whatever is read is evaluated and its value is printed. The basic unit of interpretation is the Lisp form. Whenever a Lisp form is encountered, the interpreter evaluates that form and returns its value. The simplest Lisp form is the atom. Lists are also Lisp forms. When a list is to be evaluated, the first element of the list is taken to be the name of a function. The rest of the elements are considered to be arguments to that function. In addition to functions, Lisp has special forms and macros. List processing procedures. Lisp provides many built-in procedures for accessing and controlling lists. List can be created directly with the list procedure, which takes any number of arguments and returns the list of these arguments. Haskell. Haskell is an advanced purely functional programming language. An open source product of more than 20 years of cutting-edge research, it allows rapid development of strong, concise, correct software. Haskell makes it easier to produce flexible, maintainable, high-quality software. Haskell features lazy evaluation, pattern matching, list comprehension, type classes, type polymorphism. Haskell has a strong static type system. Miranda. Miranda is a non-strict, purely functional programming language designed by David Turner. This is the first purely functional language to be commercially supported. OCaml. The objective OCaml system is the main implementation of the OCaml language. Features of OCaml language: a static type system, type inference, parametric polymorphism, tail recursion, pattern matching. OCaml basis: declaring variables. Variables in OCaml are immutable. Declaring functions. OCaml functions don't have explicit return. The return value is the last statement. Erlang. Erlang is a programming language used to build massively scalable soft real-time systems with requirements on high availability. Some of its uses are in telecoms, banking, e-commerce, computer telephone, and instant messaging. Erlang's runtime system has built-in support for concurrency, distribution, and fault tolerance. Erlang has 8 primitive data types: integers, atoms, float references, binaries, bits, ports, funds. Integers. Integers are written as sequences of decimal. Distinct integer arithmetic is exact and only limited by available memory on the machine. atoms are used within a program to denote distinguished values. References. References are globally unique symbols whose only property is that they can be compared for equality. Binary is a sequence of bytes. PID is short for process identifier. PIDs are references to Erlang processes. Ports are used to communicate with the external world. Messages can be sent to and received from ports, but this message must obey the so-called port protocol. Funds are function closures. Funds are created by expressions of the form. Let's see why are we now turning to functional programming for real-world software development. There are four primary reasons for functional programming's newly established popularity. Functional programming offers concurrent without tears. Functional programming has concise, understandable syntax. The abstract nature of functional programming leads to considerably simpler programs. It also supports a number of powerful new ways to structure and reason about programs. Functional programming offers a different programming perspective. Functional programming allows you to think differently and simply about problems that you encounter when design and writing applications. Functional programming is become more accessible. Functional programming have more language option, tooling, IDEs and etc. Real-world applications of functional programming. Erlang, used to implement fault-tolerant telecommunication system. Lisp, used as the basis for several applications on early Apple Macintosh computers. Real-world applications of functional programming. OCaml, used in areas such as financial analysis, driver verification, industrial robot programming and static analysis of embedded software. Haskell, aerospace systems, hardware design and web programming. Using the functional ideas, Google has developed a framework called MapReduce for processing massive amounts of data in parallel. Lisp is used for artificial intelligence applications. Knowledge representation, machine learning, natural language processing, modeling of speech and vision. Embedded Lisp interpreters add programmability to some systems such as Emacs. Scheme is used to teach introductory programming at many universities. Functional programming languages are often used where rapid prototyping is desired. Pure functional programming languages like Haskell are useful in context requiring some degree of program verification.